Hi, my name is Mark Smith. I didn't realize it was that kind of meeting. Um, Call sign is N6MTS. I've been a ham since 1992 when I was in high school. Was active all through high school and college, and then in the 20s I was never really inactive, but it's always been kind of a hobby of mine. And then in 2021, I spent, or I finished up my 30-year career in IT, networks and system administration and information security and all that kind of fun stuff. And I decided that starting a hardware company during a global semiconductor shortage was less stressful than my job at the time. So I left my job in IT and started a company called Halibut Electronics. Electronics has always been a hobby of mine. I studied a little bit of electrical engineering in college, um, and so I had some background in it, but I'd never really done it professionally until this company. But I've been a ham for 30 some odd years, and I've been into electronics for 30 some odd years, 40 some odd years. Um, and I decided it was time to dive into my passion. And so that's what Halibut Electronics is. I'm also a sometimes host of a podcast called the Ham Radio Workbench. You can find us at hamradioworkbench.com or any podcatcher. Just look for Ham Radio Workbench. I warn you, it is a long show. Our episodes are typically about 3 hours. So if you don't have time, and it comes out every 2 weeks. So if you don't have time to invest, maybe not get started. But anyway, okay. So today there are two things I primarily want to talk about, and they're related. The first one is a standard that I'm proposing for the interface between the user and the radio called OHIS. And the second one is a device that I designed that uses OHIS to solve a problem that it sounds like you all might have had at the most recent field day, which is a lot of noise, conversations going on around people who are trying to operate and wanting to kind of isolate that and do that stuff there. Does anyone have any strong opinions about which one I talk about first? All right. I'm going to go into OHIS first because to me this is the more important of the two. All right, let's start out. What is OHIS? Let's take a look at the words. Open, headset, interconnect, standard. What does that mean? Open means that it is a standard that I want everyone to adopt. This is not a proprietary standard. It is an open standard, open in the sense of like open source, free software, that kind of stuff. It is something that you don't have to pay any royalties to adopt. I want everyone to adopt this for free. Open headset. I use the term headset as sort of a shorthand to mean the interface between the radio and the user. It doesn't have to literally be a headset, but it's the kind of things that you find on a headset, like headphones and microphone and PTT are really the signals that we're going to be talking about here. Interconnect, meaning I want to be able to connect between a radio and a headset or headset-like things, and maybe things in between. And standard, meaning that I want you to be able to plug any device into any other device. All right, so let me define the problem that we're talking about. If you go out and buy yourself a snazzy Radio Sport headset, you spend $400 on one of these things, or maybe $300 on a Heil Pro 7. When you buy that headset, it comes with a couple of plugs on it. And there are very few radios that you can plug this directly into, right? What you end up doing is you end up buying an adapter that goes from this particular headset to that particular radio, all right? And the adapter is unique to the pairing of those two devices. If you then go out and buy a different headset, you need a different adapter. If you then go out and buy a different radio, you now need two new adapters because the adapter adapts the pairing of devices. And when you have a lot of radios and a lot of headsets, that ends up becoming a problem. In a home shack, that's not that big of a deal, but here at an EOC, right? You got a bunch of different radios in there. I don't know what brands they are. They may not be the same, and they may not be the same brands as what you have at home or at what the other EOCs have. But if you go out and you buy your own headset and you want to take that headset into the EOC because it's already got your ear goobers in it, you don't want to put on, Keith's headset that's got Keith's ear goobers in it, right? We don't. I'm going to throw you under that bus, Keith. Well, Matt did. Um, so like these are personal devices, the headsets, and so I want to be able to use my headset and sit down at any radio and just plug it in and have it magically work. I don't want to have to know what radio I'm going to sit down at first and make sure I have the right adapter for that radio. I want to be able to have a standard interface between my headsets and my radio so that I can just plug that headset straight into that radio. And that's what OHIS is. It is an electrical and physical standard that I have defined. It's all written up. You can go look at ohis.org. And the standard is there. It covers microphone signals, headphone signals, and a PTT signal and a little bit of DC power, all in a single cable that you can then connect from any headset to any radio. In a perfect world, all the manufacturers would adopt this standard natively, right? You'd have an OHIS port on your Flex radio, and an OHIS port on your ICOM radio, and an OHIS port on your Yaesu radio, and Kenwood, and so on and so forth. It's gonna be a while before we get to that point, just because of reality and radio manufacturers like their own standards, but I believe we can get there. And same thing with the headsets. You go out and buy a Heil headset, ideally one of the options for the cables from the Heil would be an OHIS plug on the other side, or the Radio Sport, an OHIS plug, and so you just have direct headset to radio connectivity. It's going to be a while before we get there. We need to get adoption first to be able to convince the radio manufacturers that they want to do this. So how are we going to get that adoption? Well, remember that one adapter I mentioned before that goes between this headset and this radio. I'm going to take that one adapter and split it into two parts. Now I have an adapter for my headset that is unique to that headset but doesn't care what kind of radio it plugs into. And now that headset presents a standard interface, right? It adapts whatever that headset is to the standard interface, and it stays with that headset. So I've got an example of that right here. Here is my Radio Sport, and I have an adapter that converts my Radio Sport into the OHIS standard. On the other side, I have a different adapter that converts the Heil, whatever it is, into the OHIS standard, right? So we have that on the headset side. Then we do the same thing on the radio side. I now have an adapter that converts whatever my radio is into the standard, right? And so now I've got this standard layer in between my headsets and my radios. And once all of my radios have an OHIS port on them, and all of my headsets have an OHIS plug on them, I can now plug any headset into any radio. And in a situation like an EOC, if you put a radio adapter on each of the radios, now you as club members can buy your own headset and bring it in and buy or build your own headset adapter to make it OHIS compliant. And now you can plug that into any radio in the EOC that you want, and it will work. Once you get everything tuned up, like that adapter has to be tuned to that headset and your voice. The radio adapter has to be tuned up to that radio. But once those have been adapted, when you plug your headset into that radio, you don't have any adjustments to make. All of that has been standardized in the middle. It will address the fact that some microphones are electret and some are dynamic. It'll address the fact that some radios put out speaker level, but others put out headphone level. Some are mono, some are stereo, some are 1/4 inch, some are 3.5 millimeters, some are those 8-pin rounds, some are RJ45, all of that. All of that variation is addressed by the adapters that make up the OHIS. That's why I say it converts whatever the radio is into a standard interface. That adapter is what does that magic. So that's OHIS in a nutshell. It is an open standard. I want adoption. And so, yes, I sell hardware that adapts, hardware OHIS adapters. I don't want to be in that business. If you want to make your own adapter, I will go out of my way to help you build your own adapter, help you design your own adapter, and not buy something from me. If you want to start a business and sell adapters to compete against Halibut Electronics, I will help you design that adapter and make it as good as you can so that you are competing against me, because the adapter business is not what I want to be in. I want the adoption, right? So that's OHIS in a nutshell. Are there any questions on that? On what it is or why you would want it? Say again, Matt? What kind of adoption have I seen so far? So none of the, we'll call it 5 big manufacturers, Flex, Elecraft, Kenwood, Yaesu, or ICOM. None of them have put OHIS ports on any of their devices. I have been able to talk to 4 of the 5 because Kenwood doesn't go to any of the shows. And the representatives of those 4 of the 5, 2 of them have been CTOs and the other 2 were sales reps in the country. All of them have said, that is a great idea. I don't think it'll ever happen, just because of their cynicism of having been in the industry for decades. However, if you get all of the other ones to agree to do it, then we will do it too. And I understand that, and I respect that. They don't want to be the only one to adopt a standard that doesn't actually become a standard, right? I can respect that. I don't begrudge them that response. And so what I need to do, and what I've been kind of partially doing over the years, is get all of the manufacturers into a room or on an email thread and say, all right, y'all have told me individually that if you can get the others to agree to this, that you'll adopt it as well. And then just get them to actually say that out loud in front of the other manufacturers. And hopefully that'll, I wonder, like if we're never able to get Kenwood on the call, whether 4 of the 5 would be enough. I don't know, they'd probably use that as an excuse not to do it. But anyway, so there's that path. And then there's also the path of getting so much adoption that the community, us, our users, the radio operators, start calling them up and say, why doesn't your radio have this standard port? It's a standard, it's well established, it's been adopted. Why does your gear not have this? And eventually, if we get enough adoption, they'll adopt it, right? They did that with USB. Took them a while, but they finally got USB in there for both charging batteries and for like doing CAT and audio and stuff like that. Also, even before that, the kind of the weird DIN connector on the back of mobile rigs for the data port, that was standardized, things like that. But the old days of having that 8-pin round connector for microphones, they standardized on the connector. Great. They did not standardize on the pinout or even what signals go where, or like what signals are on the pinout, right? And so that doesn't help. So yeah, it's an uphill battle. Any other questions? Sorry. Yes. So the question is, what physical connector are we using for the standard? And the answer is that I am using shielded Cat5 cables. They are like Ethernet cables, but they are not running Ethernet over them. The standard is entirely analog. Really quickly, if you're an electrical engineer, this will make sense. The standard is electret microphone level with an entire pair for the microphone, so mic plus and a separate mic ground. Mic has its own ground return. Headphone left, headphone right, headphone ground. Headphones have their own ground return. And then PTT and power ground, a third ground. And then the 8th pin is VCC, so 5 volts at about 200 milliamps. So those are all the signals that are on the cable. It's all analog, and it's all over shielded Cat5 cables. This is an RJ45. Did I say something else? No, okay. Yes, this is an RJ45 connector. The standard says shielded. The important part of that shield would be the microphone connector and or the microphone cable because it's the weakest signal. It's going to be most susceptible to noise. But the standard does put that microphone on a pair. So if the designer of the adapter that is consuming that signal treats it as a pseudo balanced, then you should be able to cancel out a bunch of noise. You can get away without shielded cables, but for safety, I put shielded in the standard. The advantage of doing it this way is that you can also run it through structured wiring in a building, right? So let's say you've got an Ethernet port in that EOC room and it goes out to a data center room and then on a patch panel there, and then you've got another cable going over to the sheriff's office, right? You can use the existing Ethernet wiring, patch it into the office, give him or her a user adapter so that they can plug their headset in, run the cable through all of the wiring into here and plug it into a radio, and that it will work as a valid OHIS connection. So you can use all of the standard structured Cat5 cabling that a lot of buildings already have. Cat5 or better. Does that answer your question? Cool. One of the things that came up when we first started developing it is they wanted somebody wanted a ruggedized connector because RJ45s are not the most resilient things in the world. There are two answers to this in the OHIS spec. One of them is there's a connector called EtherCon. Are you familiar with that one at all? It is an RJ45 inside an XLR shell. Like a 3-pin XLR microphone connector, that shell is just big enough to stick an RJ45 in there. And it's used a lot in stage production. And it is literally sending Ethernet in, over these big long snake cables between, the stage and front of house and back of house and whatever else. But they want those connectors to be rugged, and so they put them in the XLR shell. And it is completely compliant with this. I can plug this non-EtherCon cable into an EtherCon socket, and it works just fine. So we specified EtherCon as one of the rugged options. I also specified a pinout for DE9, like a 9-pin D shell connector, because that also makes a really good rugged cable, even though it's not compatible with these. But it's super easy to make by hand. They're very rugged. They're shielded, and they have enough signals for all the things that we want it to do. So it works really well. Any other questions? So the question is whether there's any group behind OHIS. There is the OHIS working group, which has one active member right now. I am open to other people joining it, and there have been plenty of other people who are active on our Discord where they are Oh, I didn't answer this question. You asked what kind of adoption was. Of the big five, that's what I explained earlier. There have been a number of smaller DIY projects or open source projects that have added OHIS to their stuff. And they are the ones who are really active on the OHIS Discord. So there is some adoption from people making devices for amateur radio, and they stick an OHIS port on there because it's cheap and easy to do. There's a guy named Mark out in the UK, G1LRO, I think is his call sign, and he made a thing called the Universal Radio Controller, which is it's like an all-in-one cable. Are you familiar with the all-in-one? Anyway, USB out one side and a bunch of audio and serial out the other, and he put it in a box with all kinds of connectors on it, and he added OHIS connectors on there. The Module 17 project, which is part of the M17 project, on at least one version of their hardware, they stuck an OHIS port on there. And then there's another person named Caroline who is developing her own adapters as well, and I've been helping her with that. Those are the ones that I know of. Having said that, I've also had other people ask me questions about it, and I'm not sure what they've been building. They haven't given me any details of what they're building. So there isn't like an ISO or a TIA, EIA, or IEEE or any of those kinds of standards bodies that are involved in this. However, as people start saying, yeah, that's cool, I want to build it too, I will be trying to get them more active into the OHIS working group. Uh, somebody's has a phone that's going hello. I don't know who that was. Anyway, um, so the question was, uh, I've talked about adoption from radio manufacturers. What about headset manufacturers? So there are kind of four different categories of headset manufacturers that I think are relevant. And if you've come up with another one of these four, other than these four, please let me know. But the four that I can think of are Heil, Arlen, which is Radio Sport, um, the cheap PC gaming headsets that you can get on Amazon for about $40, and aviation headsets. Somebody is, hello? Whose phone is that? Yeah. Somebody got pocket dialed. Okay. And so those are CTIA is the PC gaming headsets. We're never going to get them to do anything because they're all not ham radio specific. Same thing with aviation headsets. I'm not expecting them to adopt, although that would be pretty cool. But the aviation headset manufacturers, they already have their standards for the aviation headsets. But I know a lot of hams who have their own aviation headsets and want to use it with OHIS. And so an adapter that converts from aviation to OHIS is a kind of an obvious thing. And then the last ones are Heil and Radio Sport. Good news with Radio Sport, it is already OHIS compliant electrically. All that's needed is a cable with a very specific wiring that goes from the 6-pin mini XLR on this side, which is the connector that he has on the headsets and goes into the cable, and then has an RJ45 on the other side with the right pinouts. I have talked to Dave about this. He seems intrigued, but wasn't willing to create yet another cable to do that. So I want to make that cable. I am in talks with some manufacturers that can do custom cables and whatnot. I don't want to build it in-house. That's just not something I want to do. But I want to specify it and give it to a manufacturer and get those cables made. And so now I can say, here is an OHIS cable for your Radio Sport headset. And then Heil. Before Bob passed, I had a conversation with him about this, and I don't want to talk crap about Bob. Bob did a lot of really good things for this hobby. But if you had an idea that wasn't one of his and was different than him, getting him to realize that you're talking about something else was a challenge. And so I don't think he ever even understood what it was I was trying to do. Having said that, they also have the separate, the 6-pin XLR in the cup of their headset. And so for those headsets, we could make a custom cable that would do it. Otherwise, you're looking at an adapter for that as well. Now that Bob is gone and somebody else is running the business, I don't know who's making the decisions now. That might be a different conversation now than it was 3 or 4 years ago when I had it. So the question is whether OHIS addresses the buttons that are on microphone connectors. Like for ICOM, there are a bunch of buttons on the handheld mic that come with it, and the radio can tell which button is being pressed by what value of resistor that button shorts to ground. No. And because there is no standard of what buttons are available, all the radios have different functionality for that. And so OHIS doesn't address that at all. The way my particular adapters address it is when you plug the cable from the mic port on your radio into the radio adapter, my Radio Pro, which is this device right here. It has the port on the back that you plug in toward the radio, and then it exposes that same port on the front. And so you can plug the radio's stock microphone into this, and it just passes through. So you can still have your radio's stock microphone, handheld mic with all of its buttons that are unique to that radio, connected to that radio, And then when you hit PTT on OHIS, this thing keeps drooping down. When you hit PTT on OHIS, the only thing that the adapter does is it switches over the microphone from the stock mic on pass-through to the OHIS microphone. That's the only thing that has to change. So all of the buttons, you haven't lost that functionality, but OHIS doesn't try to extend that functionality. Because what buttons would you include in the standard? Up, down, a 10 keypad, but some radios have really complex button fields and switches and things, and it's just there isn't enough of a standardization there to try and make that not crazy. The one thing that I want to add are Morse code paddles. I would love to add a way of signaling left and right paddles through OHIS. And I don't have that right now. There are ways that you can kind of get it through the PTT line, actually using the resistor ladders like you were talking about and sending different voltages down that line. But making that backward compatible with the existing OHIS is a bit of a challenge. So for the time being, I've stuck with microphone, headphone, and power. And PTT and power. Keys are very standard, yeah. But I've only got 8 pins and they're all spoken for. So the challenge there is how do I add more signaling onto the thing without compromising some of the other stuff that we've done. Okay, so that's OHIS in a nutshell. Let me move on to the other thing. Once you have a standard between the user and the headset and the radio, now you can build devices that go in between the headset and the radio a lot easier. Because without a standard, now all of that variance of what kind of microphone it is, what are the cables, what are the connectors, and all of that fun stuff, if you want to build something that sits between the user and their microphone and then the radio on the other side, that device now has to have all of that complexity. But as soon as you abstract that complexity out into these adapters, and I've got a standard interface in the middle, I can build a device to that standard interface and not have to worry about all of that complexity. So it makes it a lot easier to build and design devices that operate on your microphone audio or your headphone audio or your PTT, and without having to make it so complex to work with every single radio and headset that you have. So the first one of those devices that I built is what I call a contesting console. The contesting console is a device that I designed specifically for field day because that's what I think of as a contest. Real contesters laugh me out of the room when I tell them that, but that's a different story. Contesting console allows you to connect 2 users to 1 radio. All right? So think like you have a logger and an operator at field day. The operator is the one on the radio. They got the mic. They're hitting the PTT. They're calling CQ or doing whatever they do. And the logger is the one sitting there at the laptop. They both need to be able to hear the radio, but they also sometimes have to talk to each other. It's like, what was that a KN for? Or, whatever. They need to be able to talk to each other without having to constantly pull their headphones off of their heads. And so they have an intercom. So the 2 users can talk to each other through their intercom. And then whichever user presses their PTT, their microphone audio gets sent to the radio, but not the other one. So it's a way to have 2 users, a logger and an operator, both listening to the same radio. They can listen and talk to each other, and then one of them or the other can PTT and key the radio up. No, the question is, how do they talk to each other? The mic is always live for the intercom. The mic is always live for the intercom. So when you put on one headset and your neighbor puts on the other, you can always hear each other. I have used this at field day for a few years now, and it is awesome, if I do say so myself. We've got a lot of clubs that have been adopting. I think I've had about 10 clubs now that are using these at their field day events, and I've gotten positive feedback from every single one of them, talking about like how did we do this before we had something like this. So I've got contesting console up here to demonstrate. If you want to come back or come up after the meeting is done, I'm happy to sit you down and show you how it works. There are a few other features of the contesting console. For example, if you're the two operators are sitting there working on the radio, and they're busy operating, and all of a sudden someone comes up and says, "Hey, dinner's ready." You don't want to miss that message. So one of the things you can do is you can turn up an ambient microphone. There's a microphone sticking out of the side of the thing that just listens to the ambient noise going on around you. You can turn that up and add that to the mix in your headphones so you can hear what's going on around you. When someone comes up and says, "Barbecues are done," great, QRT, I'm gonna go eat, right? Or if there's a whole bunch of noise going on around you, you can turn that down and block out all of the noise. And if you've got good noise blocking headsets like these Heils or Radio Sports, all of that goes away. The other side of that is, let's say Keith is doing his job and brings by the mayor and wants to show off what field day is all about. Well, the mayor or anyone that you want to demo to, they can hear the operators because the operators are speaking out loud, right? But they can't hear the radio because the radio is going into the headsets. So there is a speaker amplifier in here, and if you turn up this knob, there's just, it has a speaker that you can turn up to play to so that everyone around you can hear what's going on the radio, or at 3 o'clock in the morning when everyone else is trying to sleep, you turn that down. So all of that is adjustable. And then the one final feature that was added, because I have some YouTubers who use this, they wanted a line out that mixes microphone and both microphones and the radio into a line out so you can run it into a recorder. That's also on there. But yeah, that's Contesting Console in a nutshell. Any questions on that? So this is exactly the situation that got all of, okay, the question was 2 radios, 1 operator, SO2R. This is why I get laughed out of the room by real contesters, because when I first designed this and named it, I didn't know about SO2R. And they're like, "Oh, you built an SO2R box." I'm like, "What is that?" And yeah, they explained to me how all of that works. I'm like, "No, that's not what this is." SO2R is a different problem from a audio architecture, how like the signals get mixed and what goes where. This can't do it. I have another product that is in development that will be able to do it with the right firmware load. That is on the back burner for various reasons, because I'm trying to not squirrel around on all the different product lines at once, and I'm working on some other product lines right now. But when I get back to that one, that will be able to do SO2R. So that's on the radar. Yes, sir. So the question is Contesting Console also open source? No, it is not. So earlier when I said I will help you compete with me on the OHIS stuff, that was about adopting the OHIS standard, right? And I'll still do that. If you've got a product, if you're making your own Contesting Console and you want it to use OHIS, I will still help you integrate OHIS into your product. But no, Contesting Console is the value add that I bring to the OHIS. That is not part of the open standard. So I've got a bunch of products in this kind of category of between the user and the radio that I'm working on. The one that I talked about with you for SO2R is actually SO4R, technically, from a hardware perspective. So if this connects 2 users to one radio, the other device is what I call a station console. It connects 4 radios into one user. All of the receive audio gets mixed together and sent into your headphones. Your microphone gets amplified and split out to all 4 radios, and then you've got a selector to select which radio gets the PTT. And so like when I'm sitting at my desk at home, I've got my Flex 8400, I've got my D700 VHF UHF radio, I've got my ICOM 9700, and I've got my computer. And a radio doesn't have to actually be a radio. It's anything that generates a headphone signal and consumes a microphone signal. So my computer is a radio in this context, and I'll plug all 3 of my actual radios and my computer into this 4-in, 1-out box, and I won't have to move cables around when I go from one radio to another or anything like that. I just select which radio I'm using at any given time and press the PTT and it goes through to that. So that's the one that's going to have the special firmware that will work with one user headset and plugged into more than one radio. And then I've got a bunch of other ideas of things that can be done on the OHIS standard. But those are all the unique products that I am designing. Those are not the open source stuff. Any other questions? How are we doing on time? I didn't pay attention to when I started. Okay. Okay. I've got all the stuff up here for demo. If you want to come up afterwards and play with it and see how it works, please do. I'll happily show you more hands-on stuff then. Thank you very much.
All right.